Hey, Honors Geo students, welcome back. Today, or on this section, we're going to be working on Objective 4, which is dealing with exponent properties. This is one that I think that most people do pretty well with because the properties are pretty intuitive, they make sense, and they're pretty quick to work through. So let's get started on these, okay? I'm going to remove myself here. All right, let's jump in. So we're talking about exponents, we're talking about rules, but let's kind of see if we can intuitively get to the rules here, okay? When we look at the first one, it says to evaluate the following expressions, and we're not using calculators for this stuff because we really don't need them. When we see it says to the fourth power, think about what this means. This implies we're taking -1 and we're going to multiply it out 4 separate times. Now I want you to think about what this means. If I have a negative times a negative right here, that's going to turn into a positive. If I have a negative times a negative, that's going to turn into a positive. So when we multiply two positives together, the overall answer for this is going to equal a positive. Now ignoring the signs, if we just did 1 times 1 times 1 times 1, this means my answer for this is just going to be a positive 1. Now let's look at -1 to the 5th power though. This implies we're going to have a -1, but we're going to have it written 5 times. So I have a -1, -1, -1, -1. We're going to have that 5 times. 2 negatives make a positive. 2 negatives make a positive, and then we still have this extra negative going on right here. When I go ahead and multiply these together, I get 2 positives, multiplied gives me a positive, but I still have this extra negative. And what's a positive times a negative? This is going to equal overall a negative. And so we have -1 times, or so we have 1 times 1 times 1 times 1. We end up with just a -1 for the overall answer here. Okay, let's go back to a different number than 1. Let's go to 2. Ready? This 4 implies that we have a -2 written 4 separate times. That's what the exponents mean. And so we have a negative times a negative, which is a positive. We have a negative times a negative, which is a positive. And then we have a positive times positive, which is a positive. And when I say 2 times 2, that's 4. 2 times 2 is 4. And then 4 times 4 is positive 16. So what we're trying to get at here is there some sort of pattern that happens when we're dealing with positives and negatives? With the whether it's positive or negative based on the exponent. That 5 is going to tell that we have 5 of these 2's going on. Okay, so let's multiply these out. -2 times -2 is 4. -2 times -2 is 4. And then we still have this other -2 here. Multiply these together, we're going to get 16 times -2. And multiply those so we get a -32. So we end up with some positive answers and we end up with some negative answers. The question is, when do we get positives and when do we get negatives? Well, hopefully you can see that it is very easy to determine based on whether it's an even or an odd exponent. So based on the values of A through D, what can we conclude about a negative number raised to an even? So when we have even exponents versus when we have odd exponents, okay, we're going to end up with, in these cases, we're going to end up with a, let me write this out. Right here, this is going to end up being positive, and this right here is going to end up being negative. Okay? So, based on that, we can use that pattern to kind of work through some other problems relatively quickly, whether it's going to be a positive or a negative. So, for example, if I have -1 to 75th power, when we look at this right here, that is an odd number. And so when we look at this being an odd number, we can say that the answer for this is going to end up being a negative number. Okay? When we look at this, this is an odd number. So when we multiply this out, this overall is going to end up being a negative number. When we have an even number right here, that tells me that this negative that's right here just comes down, but this value right here is going to be a positive number overall. However, because I have a negative times that positive, my overall answer would end up being a negative. Okay? When we look at this is an odd number. However, this value right here is not negative. And therefore, there's no reason we would end up with a negative number. So this is going to always be positive. Think about what that 4 to the 15th power is. That's just saying 4 times 4 times 4 and so on and so forth. Right? So we have 4, 15 separate times. There's no negatives getting incorporated there. If I say -2 to the 5,324, well, this is an even number. So that means we have an even number of negatives, which means that this overall answer will be a positive. Okay? Let's go ahead and simplify each one of these without a calculator. We did these back in our first day of notes. When we look at this right here, what this says is we have the opposite of 2 times 2. That's what that 2 squared means. And remember, that's very different than the next one. but we look at this, we have -4 for the overall answer. This one says we have -2 to the second power, which means we have -2 times -2. That means that we end up with a +4. This -2 to the third power, that's an odd power. And so if we think about what's going to happen, we have -2 times -2 times -2. We have a +4 times -2, which means we have a -8 for our overall answer there. Okay, not 6. Be careful with that. And then this last one, that negative is not in parentheses, so it's not being cubed. So we just have a negative in the front of the problem. And then we have a 2 to the third power. Well, 2 to the third is 8, so this is going to be a -8 overall. Okay. Here, what we're going to be doing is we're going to evaluate the expressions when x is equal to -3. So we're going to replace every x with a -3. Make sure we use parentheses for the substitution there. So if I replace this x with a -3, we have -3 squared minus 2 times -3 plus 4. We'll use our orders of operations to simplify. Excuse me. We have 9 plus 6 plus 4. Okay, -3 squared is -3 times -3, so that's a 9. And then we have 2 negatives right here, which is going to turn into a positive. So we have 15 plus 4, which is, excuse me, 19. Okay. All right, letter B. We have 4 raised to the 6 plus 4 over 3 times -3. And so let's do this off to the side here. 6 plus 4 over 3 times -3. Okay. That means we have 6 plus, this will be -12 over 3. That means we have 6 plus -4. So 6 minus 4 is just 2. So if we simplify this, we're going to have 4 to the 2, because all of this right here is just equal to a 2 when we simplify that. And 4 to the second power is just 16. Okay. All right. Let's continue on. So we're going to be taking and just condensing and expanding and working through some rules here, okay? We have a 3 here. There's only one 3. But then we look at the a's. There are 4 a's right here. So this simplified is just going to be 3a to the 4th power. When we look at the next one, we have a 2 here. But then there are 5 x's here. So we're going to have 2 times x to the 5th power. All right. So let's talk about product rule. When we have x to the a times x to the b, the simplified form of this is x to the a plus b. Multiplication turns into addition. Multiplication into addition. This is going to be the same when we get into logs at a later time. So multiplication turns into addition. And think about what this is. If I had x to the second times x to the third, this is like saying 2x's for the first part times 3x's for the second part. And you look at the combined total number of x's here, there are 5 x's. Well, how do we get that? You would take and go x to the 2 plus 3, which is just x to the 5th. Okay? The power of a power rule says that we're going to take the powers and we're just going to multiply them together. Why is that the case? Well, if I have x to the 2 raised to the third, think about what this says. We have x times x raised to the third. So what that means is that we have x times x 3 separate times. Well, look at how many x's we have. We have 6 x's. So to simplify that, we could just say x to the 2 times 3, which is x to the 6th. That's why that rule is the way it is. All right. With subtraction, the quotient rule, this is, again, division just turns into multiplication, subtraction, right? We see the minus sign right there. So division turns into subtraction. Why is this? Well, it's a very simple rule. Right? If I have x to the a over x to the b, it's just a minus b. The reason this is let's say that I had x to the 5th divided by x to the 2nd. What ends up happening is you could say that we have 5 x's in the top and there's only 2 x's in the bottom, right? So there's a battle that's going to happen, right? There's 5 on the top, there's 2 on the bottom. And if we think about a little battle happening, they're going to cancel each other out. Why is that? Well, what's any number divided by itself? It just equals a 1. Any number divided by itself is just equal to a 1. So we're left with 3 x's here. And so what's the shortcut for this? We could have just simply said that x to the 5 minus 2 is 3. I'm going to try to make your life a little easier, though. When you're doing this, instead of going through and doing all the subtraction and figuring out time, like all this, just look at who has more. If there was a fight that's going to happen, you got 5 friends and 2 friends, who's going to win the fight, right? The group that has more people. So 2 are going to get taken away from this group, and 2 are going to get taken away from this group. That means that we're just going to be 3 remaining. Okay. All right, so let's go ahead and simplify. Rule number 1. Okay, so we're going to take the 2 and the 3. When there's multiplication, we're just going to add these together. We get x to the 5th. Okay. For the next one here, and if you're not sure, until you're comfortable with the rules, feel free to write things out if you're just not used to them yet. This first one right here, this answer should be 10 times x to the 7th. But where does that come from? Well, if we look at what this part says, that really says 5, and then there's 3 x's there. That 3 is not being applied to the 5. Okay, remember, that's not the same as if I had said 5x to the 3rd. These are not the same. Okay, these are not the same. All right, and then this other thing, this says 2, and then there's 4 x's on here. So if I multiply all this stuff together, 2 times 5 gives me that 10 that's there, and then there are 7 x's involved. Okay, let's look at the next one. We're going to add these together. 3 to the 12 plus 27, which is 3 to the 39th power. Do not actually try to multiply that out. You'll get a massive number. You'll break your calculator. All right, rule number 2, power to a power. So we have x to the 2 times 3. So we have x to the 6th. Okay, and the next one. Again, if you're not sure about these, you can write them out. But to break this down, this is negative 2 to the 3rd power. Then this is x to the 2nd to the 3rd power. And then it also says y to the 3rd power. That 3 gets distributed to everything inside of your parentheses. So we end up with a negative 8, x to the 6th, y to the 3rd. So this is your answer. Now, if you're not comfortable with the rule, I discourage doing this, but until you get comfortable, feel free to do it. Think about what this says. This whole thing says we have a negative 2, 2 x's, and then a y, right? But it says we have this whole thing 3 separate times, right? So I'm going to take this and write it out. We're going to go ahead and duplicate this. We've got 1, 2, 3 times, right? That's what that 3 means. And if we go ahead and multiply everything out, there's a negative 2 times negative 2 times negative 2, which will give me that negative 8 that's there. Okay. There is, when we look at the x's, there's 2, 4, 6 x's here. Okay. And if we look at the y values, there's 1, 2, 3. So there's 3 y's in this problem here. Okay. Long way, short way, I don't care. Just get there. At the end of the day, try to figure out how to do the short way, though. Okay. For letter C, we're going to do the same thing here. So when we look at this, these are going to get put together. We're going to have 5 to the 2x. And then we're going to take these and put these together. This will be 5 raised to the 12x. Again, you're multiplying powers. But now let's go ahead and combine our rules. When we have a 5 to the 2x and 5 to the 12x, we're going to take these and add these together. And we end up with 5 to the 14x as our final answer. Okay. All right, let's go on to rule number 3, which is our little battle one. Who wins the battle? Okay, and we're going to do these part by part because I want you guys to see these in action, all right? So 2 and 6, they don't have the exponents attached to them. So we're just going to reduce these. 2 divided by 6 is just 1/3. Okay. Look at your x's. There's 5 x's on the top and 3 on the bottom. Who's going to win this battle, right? There's 5 on the top, 3 on the bottom. So we're going to simplify these. There's going to be 1, 2, 3 will go away. That leaves 2 remaining on the top. So x to the 2nd, that is your final answer. Now you won't see it written like this. Normally you'll just see it written as x to the 2nd over 3. But you'll find that I just like to go ahead and separate things just so you can really clearly see those parts. Okay. Next one. All right, part by part here. Let's go ahead and work through this. We'll look at the numbers in front. We have negative 6 over 9. If I reduce that fraction, divide both by 3, that's going to be negative 2 over 3. And then if I look at the x's, we have 8 and 6. So who's going to win the battle? The top is going to win because it has 2 more. That's it. Negative 2 over 3, x to the 2nd. Let's go ahead and look at this one. All right. When we look at what's on top here, there's 15 right here, but there's technically 1 more up here at this moment, right? So when we look at the 5s, there are a total of actually 16 5s on the top. And when we look at the bottom, there's 12 5s on the bottom. So now who wins this battle? Obviously the top has more, so it's going to win by 4. And there's nothing left on the bottom. That I can actually simplify. That's going to equal, 25 times 25, so 625. Okay. All right. How we feel? We okay so far? Yeah? All right, let's jump into harder problems. Now we're going to start trying to take all the rules and apply them all together. All right, and you're going to see me kind of color code these just to keep things easy. All right. If there's ever an exponent, deal with the exponent on the, if there's ever an exponent on the outside, so if there's exponents up here or up here, always deal with those first and then start worrying about simplifying hereafter, okay? All right, part by part. We look at the values in the front. We have negative 12. We move on to the next value, x squared and x to the third. There's 2 on the left and there's 3 on the right, so we have a total of 5. And then we look at the y's. There's 1 here, and there's 4 here. There are a total of 5 y's. Done. All right, next one. See how we got that exponent on the outside? We have to navigate that first. So let's take that and distribute it to everything that's on the inside. So it's going to get applied to all of this. So we're going to have 3 to the third. We're going to have x to the fourth to the third. And we're going to have y to the second also to the third. Okay, it gets applied to everything on the inside. 3 to the third is not 9. It's 3 times 3 times 3, which is 27. Multiply our powers, we're going to have 12. Multiply our powers, we're going to have 6. And there's your final answer. Okay, take this one right here. We're going to treat these like separate problems until we can combine them. So let's deal with this part first. Okay, let's deal with the 4 over negative 2. That right there is going to equal negative 2. And then look at your x to the 6th and x to the second. Okay, just look at this part. There's 6 on the top. There's 2 on the bottom. So when we simplify, there's going to be 4 remaining. Then we're going to have plus. We could do this part of the problem off on its own if you want. But when you think about negative 5 x to the second, but it's squared, that means we have negative 5 x to the second written twice. Right? Oops, sorry, you can't see. So we have it written twice. Well, handle this, right? We have negative 5 times negative 5, which is 25. And then in terms of the x's, there are 2 here and 2 more, so we have 4. You can see now that these have the same exponents for our x to the fourth, so we can combine these and make this equal to 23 x to the fourth for our final answer. All right, let's move on. Okay, this one's a little bit tougher, so let's go part by part through this. Let's deal with exponents on the outside first. This gets applied to everything. 5 to the third, remember, does not equal 15. Okay, remember that this is 5 to the third, which does equal 5 times 5 times 5, which is 125. Okay, so what we have here is we have 125 x to the ninth, then we have negative 2 x to the fourth, and then we have 4 x to the fifth. Okay, a lot going on, but let's do this just part by part. You ready? Okay, let's deal with the numbers first, the coefficients. We have 125, negative 2, and 4. There's multiplication and division going on here, okay? So we have 125, we have multiplied by negative 2, and that's divided by 4. That means we have negative 250 divided by 4, okay? And then if I try to reduce this, this doesn't actually divide out evenly, so we're going to end up with a fraction still, but simplified, this is going to equal negative 125 over 4. Oh, not over 4, over 2, sorry, over 2. All right, so that's just the coefficients. Now let's deal with our x's here, okay? There's 9 right here, there's 4 right here, and there's 5 right here. I'm just going to move them so we can see them all together. There's 9, there's 4, and there's 5. Well, on the top, there's a total of 13, and on the bottom, there's a total of only 5 still. Who wins this battle, right? The top does. There's 8 more on the top than there are on the bottom. So then this is your final answer. All right, next one. All right, so we got a power on the outside. Let's navigate that first, deal with this first. So we simplify this, we have 2 to the 5x on the left side. That's not going to change because there's no power outside of here. However, over here, we're going to have 2 to the 4x. Remember, powers multiply. And then we have 2 to the x on the bottom here. Okay. All of my bases are exactly the same. Because there are 2's involved everywhere, we can work with all of these at the same time. So if we look at the top here, these are going to combine and become 2 to the 5x plus 4x. And we still have 2 to the x on the bottom. So simplify this, we have 2 to the 9x on the top over 2 to the x on the bottom. Simplify this. We have 2 to the 9x minus that x, right? We're going to be subtracting. Like the top has more, so it's going to win the battle. And we end up with 2 to the 8x. Okay? All right, so let's talk about a couple of other rules before we jump into some bigger problems here, okay? So first off, anything to 0 power. Anything to 0 power is always going to equal 1. That rule is actually derived from your previous rule, the quotient rule. The reason that is that if I had x to the 5th power divided by x to the 5th power, anything divided by itself is 1, right? 100 divided by 100 was 1. 1,000 divided by 1,000 is 1. Anything divided by itself is 1. So I have x to the 5th divided by x to the 5th. That's going to equal 1. Well, if I use my subtraction rule, I get x to the 5 minus 5, which is x to the 0. And so what we see then is that, well, this is 1. That means that this also has to equal 1. So anything to the 0 power is going to just simply equal 1. Okay? Negative exponents, real easy. They never want to stay negative. So they always just move. So if I had like a negative up top here, it's going to move down to the bottom. And if I have a negative down on the bottom, it's going to move up to the top. So we see an x to the negative a. That's the same as 1 over x to the a. And I see x to the negative a. It just moves up to the top and becomes x to the a. It just switches sides. Okay? I'm going to try to keep it as easy as possible though when we're doing these. Is don't think of it in terms of where is there negative and positive and all that. It's just like, just keep things positive and you'll, never mind, I'm confusing you. Just let's wait till we get to it, okay? So 2 to the 0 power, we just said is equal to 1, okay? 2 to the negative 1 is like saying 1 over 2 to the first, so it's just 1 over 2. 2 to the negative 2 is like saying 1 over 2 to the second, which is 1 over 4. And 2 to the negative 3 is like 1 over 2 to the third, which is 1 over 8. And what you should notice is that these are exactly the same, right? Except that one's positive, one's negative. So 2 to the second is equal to 4. Well, 2 to the negative 2 is just 1 over 4. And so if I had 2 to the negative 1 and 2 to the first, this is 2. This is 1 over 2, right? It's the same thing, just flipped over. So if I had like 2 to the negative 3, which is 1 over 8, that should tell you then that 2 to the third would just equal positive 8, okay? Just the reciprocal. So when we look at this, this is 2 to the negative 2 and 3 to the negative 2 when you distribute it. We don't want to keep negatives, so they just switch sides. And so that becomes 3 to the second and 2 to the second. Just switch them so that they become positives, and we end up with a 9 over 4. Okay? So let's simplify these. Ready? 7 to the third divided by 7 to the third. Anything divided by itself? Anything divided by itself is just going to equal 1. Okay? Treat these like separate problems so we can just navigate them. 2 divided by 1 is just 2. Anything divided by itself is just 1. So 2 times 1 is just 2. All right? Anything to the 0 power here is equal to 1. So I don't have to worry about that. So this is just 2 times x squared, which is just 2x squared. Next one. This is to the 0 power. The 3 is not. Only the x is taking the 0 power. So I don't have to look at this. This is just a 3. This whole thing, though, is taken to the 0 power, which means this whole thing is equal to 1. So 3 times 1 is just 3. Okay, quick, easy rules here. All right, so now let's try to put everything together. Let's make this gradually more challenging. You ready? What I do is, when I'm dealing with my problems, is I deal with all exponents outside of the parentheses first, and then I take care of all negatives, move them, and then do my rules from there. So you'll see what I mean in a second here, okay? See how there's a negative here? It doesn't want to stay negative. So let's move it down. It's going to move down to the bottom and become a positive. Okay? We have a negative here. We don't want to keep it negative, so we're going to move it down to the bottom. Okay? We have a negative here. We don't want to keep it negative. We move it up to the other side. Everything just switched sides here ultimately. So now we just use our normal rules that we would. Ready? There's 5 x's here. There's 7 here on the bottom. Who has more when we have this battle? The bottom has more. How many more does it have? It has 2 more. And so now I've got this blank space at the top. So what do I use to hold that space? I fill it with a 1. And that's it. You're done. Okay. Let's look at this next one. We have an exponent on the outside. So let's navigate that first. That gets distributed to everything in the parentheses. So we have a negative 2 to the third. And then we have an x to the negative 3 to the third. And then we still have an x to the 5th on the bottom. That doesn't get that 3. Okay, let's go ahead and handle these. So this is a negative 8. It doesn't move because then when we look at this, the coefficient is negative, not the exponent. Only things that move are exponents. Okay, this we have x to the negative 9. This we have x to the 5th. Okay, negative 8 doesn't move. It's not an exponent. We have a negative exponent here, so we'll move it to the bottom. We have a positive exponent here, so it does not want to move. Okay, and let's put stuff together. We have negative 8, x to the 14th power when we put those together. All right, rapid fire these. Now that we're starting to hopefully get the hang of these, the negative gets distributed to the inside, to everything. We're going to have x to the negative 6 and y to the positive 4. We're multiplying the powers together. Negative exponents move, so this is going to move to the bottom. Okay, that y to the 4th is positive, so it's not going to move. And then we have a 1 at the top to hold that spot, and you are done. Okay, letter D. Let's distribute the negative from the outside. Anything outside gets distributed first. So we have 3 to the negative 3, a to the positive 9, b to the negative 6. Okay, let's move this. Because it's a negative exponent, it's going to move. Positive exponent stays. Negative exponent moves. Simplify from here. A to the 9th is still a to the 9th. 3 to the 3rd is 27. B to the 6th does not change. So this is our answer. Now, I've spread it out. It looks a little weird. You're never going to see it written like this, but I just want you to see the parts. But really, this says a to the 9th over 27b to the 6th. Okay? All right. Maybe pause it. Try a couple of these on your own. Okay? Because these are a little bit more challenging, but I'm going to jump right in. Okay? All right, rapid fire. I'm going to talk you through it as I'm doing it. Ready? Okay, distribute everything. We have negative 4 to the 2nd, a to the 2 to the 2, b to the negative 3 to the 2, 2, a to the 0, and b to the 4th. These are separate little parts here. Okay, on the first part, we have 16, a to the 4th, b to the negative 6. On the bottom, we have 2, a to the 0, a to the 0, and then b to the 4. Okay, keep simplifying. 16 divided by 2 is 8. A to the 0 just goes away. B to the negative 6 goes to the bottom, and there's already 4 at the bottom, so now there's 4 and 6. There's a total of 10. This is your answer. All right, let's continue on. Negative exponents gets distributed to everything in the parentheses, so it's going to go to everything in this problem here because it's all in parentheses. So we have a negative 3 to the negative 2, x to the 5th to the negative 2, 9 to the negative 2, and x to the negative 3 to the negative 2. All right, let's navigate these. Let's simplify these if we can. So negative 3 to the negative 2 doesn't simplify yet. X to the negative 10. 9 to the negative 2, x to the 6th. Okay, let's get rid of our negative exponents. So this negative exponent moves down. We're going to have negative 3 to the 2nd. This negative exponent moves up, so we're going to have 9 to the 2nd. This negative exponent moves down, and there's already 6 at the bottom. That is not going to move, so we're going to have 16. Simplify this, we end up with 81 over 9, x to the 16th. So now we have 9 over x to the 16th for our final answer. Okay, last one of these. Okay, we only have one exponent being distributed here. So we have a to the x, b to the negative 3x, a to the 4x. Now, I don't like that these are separated, so what I'm going to do is I'm going to take this. Let me rewrite that so that we have the x there. And since these have the same bases, this actually belongs over here with it. All right, then we have on the other one, we have a b to the negative 5x. And then we have this part here that's being distributed, so we're going to have a to the negative 2x. All right, let's go ahead and take care of all negative exponents, move those around, okay, so that they're positives. That a to the x and a to the 4x, I'm just going to keep that as a to the 5x. We're just going to combine those right now. This negative exponent is going to move to the bottom. So it becomes positive 3x. This negative exponent will move up. It becomes positive, or b to the positive 5x. This is also going to move up because it's a negative exponent, and it's going to be an a to the 2x. All right, let's finish up here. A to the 5x, a to the 2x, that's a to the 7x. B to the 5x and b to the 3x, they're going to subtract and leave them b to the 2x. And you are done. All right, so the last one's how do we use these rules? Well, we use these rules to try to simplify. We use what's called a one-to-one property. You're going to explore this more when we get to logs at a later time, but for right now, let's go and try and navigate these, okay? What we're looking at is trying to get the bases to be exactly the same if we can so that we can work with them. So, for example, 3 to the 3x, let's leave it as it is, but this 9 that's right here, can I write this as 3 to some power raised to the 15th? So that the bases on these are identical to each other. That's the goal here. Well, hopefully you know that 3 to the second power is equal to 9. Okay? So that means we have 3 to the 3x is equal to 3 to the 30th power. 2 times 15 is 30. Now, what do we do with this? Well, there's a rule. It says if you have a base to an x and a base to the y, if the bases are identical, we could just set x and y equal to each other. Think about it. If I had 5 to the x and I said 5 to the 4th, right? The only way these are true is if x and 4 are equal to each other, right? So it's the same premise here. I got 3 and 3 here. They're identical. That means that 3x has to equal 30, which means that x, oh no, I just wrote 10. That means that 3x is equal to 30, and that tells us that x is going to equal to 10. Okay? So now you try. All right, well, again, pause it if you want to, but let's see if we can work with these. You ready? We've got a 16 here, and I got 2 here. I want to try to get the bases to be the same so we can work with them. Okay, same thing with this right here, that 1. So here's what we could do. I have a 2 to the 5x. Let's see if we can get the 16 to be 2 to some power raised to the 2x plus 1. And let's see if we can get this 1 to be a 2 to some power as well. Well, hopefully you remember anything to the 0 power is equal to 1. That takes care of that right side. But what about the left side? Well, 2 to the 4th power is equal to 16. So now that we've got exactly the same bases, we can use our rules. We have 2 to the 5x over 2 to the 8x plus 4, and that's equal to 2 to the 0. That means that if I use my rules, I can write this as 2 to the 5x minus 8x plus 4 is equal to 2 to the 0 power. And now that my bases are the same, I could just set the powers equal to each other. So 5x minus 8x minus 4 is equal to 0. That means that negative 3x is going to equal to positive 4. And that tells you that x is equal to negative 4 over 3. And that is it. Okay, so exponents are pretty easy. There's a bunch of rules to them, but my suggestion is always take them one step at a time. Keep using the exact same step, and you'll see that they actually simplify pretty quickly and easily, okay? But that concludes the notes here. You guys take care and be well. Until next time, have a good one.